customers are asking us to look at things really through purely a supply chain lens
Yes.
and say, Shon, you're on the inside. Who can I trust to be around?
Mhm.
And if we, this concept of when you can prototype or you design something and you can print it once or even 10 times, what you haven't really proven commercial viability. You've proven feasibility. Hey, it can be done, but the still should it be done, and not only for DFAM reasons and cost per part and all that, but what's the stability of the supply chain around that powder or resin or filament or et cetera. So more and more, and these are good things because in reality, we've got to get customers looking at additive and thinking beyond just the DFAM, beyond what hardware do I need, what print volume, speed, et cetera, and looking at the big picture. Welcome to the Additive Advantage Podcast. I'm Shon Anderson, joined by Dani Mason. Between the two of us, we've spent decades working at the intersection of advanced manufacturing, additive technologies, and real-world production environments. We've been supporting companies as they move from early-stage exploration into scalable, repeatable manufacturing systems. This podcast exists because we've seen the same pattern too many times. Companies invest in additive, prove it can work, but then struggle to make it work consistently at scale and be commercially viable as a production process. This is where additive manufacturing meets accountability and where we focus on turning pilots into production and ideas into outcomes. Let's jump in.
Today, we're diving into one of the biggest challenges in additive, and honestly, one of the least talked about in a practical way, which is quality and consistency. There's a lot of conversation in this industry about what's possible with additive, but far less about what's repeatable, and even less about what it actually takes to scale into real production. We're going to break down how to think about QA and QC tool sets, where most companies go wrong, and what it looks like to build a system that delivers consistent, predictable outcomes. But first, before we dive in, we're coming off of one of the industry's biggest trade shows. I was not able to attend, but Shon was there with some of our team. I would just love your thoughts on what you saw at Rapid this year. What looked different? What looked the same? What are you seeing as trends from maybe customers and companies alike?
It was an interesting show in a few different ways. The first thing that jumped out at you when you walked in the hall is there were a handful of big booths, but not like it used to be,
Hmm.
which I think is consistent with other shows that we've seen. I think companies are getting more realistic about how much money should we spend telling each other about what we do. Rapid TCT was more additive industry players than customers this year, it felt
Mhm.
like to me. Still had some great dialogue with customers that were there. And honestly, I met with, you know, CEOs of probably a half a dozen different companies, and it was fascinating to hear them talking about what they see and what their customers tell them the challenges are
Hmm.
with succeeding. We'll get into that a little bit more
Hmm.
as we go. There definitely were some new products, people like BMF, HP. Interestingly, both of those is how do we deliver, I would say maybe not their top line performance, but good performance in a more user-friendly package at a better price point. I think it's become apparent that you can't sell, a $500,000, $250,000 piece of equipment and make the unit economics work in production, especially if the thing's not ultra repeatable. And it was interesting to me, when you look at sort of the decontenting that went on and the product decisions that were made in both those products, what the manufacturers decided they could take out to help bring the cost down and what they needed to leave in. And that's one of those things that I don't know about all of you, but anytime I see a company launch a new product, whether it be a new top end product or bottom end product, I'm always interested if it's top end. What did they think they were missing that they added in? And when they bring it out a more cost competitive or value oriented product, what was it they thought that was in their other products that customers could live without? You learn a lot about not only company strategy, but what customers are really willing to pay for by the decisions that they make around those things. So that was definitely fascinating. More and more conversation about how to make things work at scale. I think largely for the good, a ton of focus on defense
Hmm.
right now for a
Yes.
whole bunch of reasons, we don't have to get into on this podcast because you probably hear about it on every other podcast you listen to. And I think that's a good thing because it is challenging our industry to perform and deliver at scale. I think we need to be a little careful that as an industry, we don't rely on that so heavily and allow that to drive us forward so singularly that we lose track of what other customers want. A lot of the same things. Again, we'll talk more about, repeatability, reliability, et cetera. But certainly there are some differences, especially if you're working on technology that builds things that go one way, be that UAVs, munitions, et cetera, versus something that has to, perform over time. But a lot of interesting things going on in the space. Talking to one of the other things I love to do is talk to people who are leading businesses that are fairly new to additive exposure
Hmm.
and ask them what they saw. Great example. I met with a senior executive, C-level executive from Worth, who is new to that role, has been in that role about 90 days, asking him his thoughts based on what he saw. And he said, Worth has an additive division. And he said, I understood our strategy, thought I knew what was going on, got in here, saw all these companies, many of whom look like they have great products. Not all of them, I think, impressed upon him that they have a plan to be around
Hmm.
long term, which, is another bad habit we need to shake as an industry. And, you continue to see some deals happen that tend to fall into two categories, either investments in things that are usually defense related right now, or, you still see a few companies exiting the space. And I think it's going to be, with things like the nano dimension selling
Hmm.
off kind of their core technology, and then the ripple effects of that with regard to, their different material products and other things that they'd been trying to commercialize. When you see a company undergoing major transformation and the strategy like shift quarter to quarter, anybody who chose to, let's say, adopt Ataru as a material around an application, well, what did they learn? You can't depend on additive. Don't spec these materials into your process. We just have to be very diligent and more, and I'm sure you'll share more about this later, but customers are asking us to look at things really through purely a supply chain lens
Yes.
and say, Shon, you're on the inside. Who can I trust to be around?
Mhm.
And if we, this concept of when you can prototype or you design something and you can print it once or even 10 times, what you haven't really proven commercial viability, you've proven feasibility. Hey, it can be done, but the still should it be done, and not only for DFAM reasons and cost per part and all that, but what's the stability of the supply chain around that powder or resin or filament or, et cetera. So more and more, and these are good things because in reality, we've got to get customers looking at additive and thinking beyond just the DFAM, beyond what hardware do I need, what print volume, speed, et cetera, and looking at the big picture. So in reality, I think it's a little bit like being 13. You still have a lot of potential, but you're awkward and things don't always go the way that you'd wish. But man, as an industry, I can't wait for us to exit that stage. Yeah. And again, I'm not going to go super deep into the nano dimension thing or all that. There's plenty of other great podcasts that you can listen to for that detail. But
Yeah, I think that's great. We're going to talk a lot on here about moving from what's possible to what's repeatable in the system sense, but you bring up a great point. Supply chain, workforce, partnerships, they all need to undergo that same lens. Because just because you can do something once does not mean it has long term viability. I'm talking to customers and it's how can I dual source this, not just with two suppliers, but what does it look like for a hybrid integration solution? What should I vertically integrate? What should I outsource? What should I have a backup for? And oftentimes, we're having that conversation at the feasibility stage where we're even trying to figure out what's the right tech stack. They don't have that viewed as a downstream problem to figure out. They have that right up at feasibility, along with what is the tech stack that delivers the performance I need. And that has been a shift that I think has been accelerated, at least what I've seen over the past 3 months.
and a good thing.
Yes, a good thing.
It's interesting that you mentioned the workforce piece, and we hear the word workforce a lot, but usually it's in the context of, oh my gosh, there's 5 million unfilled manufacturing jobs if we're going to restore the defense industrial base or some cool infographic type thing. I'm talking about the just practical applications. So I was also in Washington, D.C. last week, met with one of the divisions of the Department of War. They're talking, again, talking about how do we use additive to speed up production of some critical things. And I asked this gentleman the question about, so you're going to bring this technology behind the gate and you're going to produce it yourself. Yep, that's what we're going to do. Who are you going to use to run the tech, run the process, essentially then certify once you've assembled, this is not just an additively printed part. There's a number of components and some other things that go in. I said, do you have a job description? Are those DOW personnel? Are those contractors? What's your plan for that? Because again, separating feasibility, could this be done? I think it can. They believe it can, obviously, or we wouldn't have been having the meeting. But practicality, and we talked about then the alternative of, do you have a supplier set up right outside the gate or very close to the gate, making parts, essentially delivering parts, putting that workforce burden on a company that actually understands additive as a production tool and allowing this division of the DOW to focus on what they do, thinking about that before you start and understanding, you hear us use the phrase a lot on this podcast. You got to pull that plant manager forward and get them involved early, because when they think about who they have in their workforce, for instance, if you're in an injection molding facility, right? I may have 1,000 production technicians very well versed in how to operate injection molding presses, do PM, all these things. If I'm going to bring in a big chunk of additive, and this is unfortunately how it often goes, is it gets put on the production floor, but the company's engineers run it to
Mhm.
start. And then they think there's going to be this handoff, but there's no training, or
Mhm.
there's, I'm going to air quote training that is like a 1 hour lunch and learn. Here's the on button. Here's how you put the USB stick in. This concept of, how do I validate the parts are good? How would I know if the machine were starting to drift in its performance? Those kinds of things typically not addressed. Thus, the technology tends to not succeed on the factory floor. That's not an employee problem. That's a management problem, right? When we don't build the right considerations into workforce. And it is a huge opportunity when every day, especially if you're a CEO, you're bombarded by, oh, AI is going to take everybody's jobs and we're only
Mm.
going to need to work 5 hours a week, which sounds good, right? But then after you've had 2 cups of coffee and you're like, okay, well, that might happen someday, but it doesn't appear to be happening today for me.
Mhm.
um, it is a huge retraining opportunity
Mhm.
to take folks whose jobs may have been impacted by AI and put them in a place that, if these are your good employees and you've invested years of time, energy, development, etc., in these people, let's put them, if those are your best and brightest production folks, help them learn how to make this new technology succeed. I preach the message over and over. It's not replacing people with technology. It's enabling people to do what they do best via technology. But if you wait to think about that workforce consideration until you think the process and the technology are baked and ready to go on the factory
Mhm.
floor, you get enormous amounts of pushback.
Mm.
A little bit of a tangent there, but it's so key to making these projects actually perform.
Yeah, I agree. I was Sean was in DC and Boston. I was in Indiana for a little bit, and we were at a site visit at a major electronics manufacturer. And one of the cool things that they're doing with their workforce is twofold. One, they have manufacturing teams exposure to additive on site at the headquarters as they're thinking about adopting this technology. And then as it moves from what I'm going to call product development, they have a separate group whose sole job is production transition.
Mm.
So it's like, how do I get the in team exposure early? And then how do I define a team that's going to be able to bridge this prototyping, product development, low volume run into a production tool? And it's really slick. They do a lot of vertical integration. So I think this mindset of, how do I take something that's new and decide when and how to bring it into my business and have it be scalable is a little baked into their DNA. But it's a great way, I think, of codifying what you're talking about, where it's not, well, the additive person will just know enough about production to be able to train the next people and deploy this. No, they're being very intentional about who is brought in at what points of this process and what's key to quality for that person to understand, in addition to what's key to quality for the system. And I was very impressed by that tour and how they're thinking about doing this globally.
Well, and certainly, I think there's a best practice to be identified there, where if you as a company see additive as key to your future
Mhm.
strategy, doing anything around production, developing a team who can time and time again help take what has been proven through feasibility, bring it to life on the factory floor, understand the workforce supply chain and all those things. But to have a team that can do that is fantastic. And for those of you that can't, that's what we're here for.
Yes, yes, yes.
Not every
We've done
company
it with hundreds.
has the resource to do that
Yes.
in-house, but it's encouraging to see, again, so many of the companies I've been to, it isn't that they don't have a process for introduction of new production technologies.
Mhm.
It's just that they forget to use it, it seems like,
Yes.
when it applies to additive, and I'm not exactly sure why that is, but their answer to making this work at scale is not rocket surgery. It's
Mhm.
actually some of the just, I'll call it boring, but
Mhm.
it's the attention to detail, execution, planning, communication, having clear objectives for what is the definition of a good part. We've seen, won't name any names, but I saw a digital production, I guess I'm going to call it specification from a very large company, a large publicly traded company. There's a section. Good news is they had a section in this specification for quality. The bad news is all it said was, are the parts this color, which, is definitely a good thing to have the right color. And that tells you maybe you printed it in the right material. There's nothing about form, fit, function, or anything else. And in the event you printed 10,000 of those parts and 9,999 of them actually didn't work very well, would it be the technician's fault?
Mm.
No. Would it be the machine's fault? Not really. You have to design, to go back to your lean production methodology, things like Poka-yoke and,
Mhm.
you know, 5S. I mean, how am I going to make it easy for my operator to tell whether these are good parts or not? And this is possible on any machine technology, any application. It's, comes back to the phrase you used a minute ago. It's understanding what's key to quality
Mm.
and then figuring out how do we make sure that's built in rather than, well, we're gonna use a $50,000 piece of metrology equipment. We're gonna use
Yeah.
a
Expect
7-minute
everything.
inspection process for every part we print.
Mhm. I wanna dive a little deeper in there. You mentioned kind of at the onset of this, where it's interesting to see what features are added or how products are de-featured, and you talked about what I would say is core to user experience, speed, ease of use, etcetera, but there's still this barrier that's around quality and consistency. How are companies building that in? And I think it's this shift from thinking about the printer as a tool to, no, actually, I design systems. That's how you need to think about this when you're implementing it. And I want to get your thoughts on that a little bit in terms of why companies keep getting stuck there, why this repeatability is still a barrier. You mentioned a lot of principles from process controls to design. Does the technician do it the same every time? Whose preventative maintenance job is it to make sure those machines are clean, material variability? Talk a little bit about maybe where we see companies getting stuck and how they get unstuck as they make this shift from I need a printer to I'm designing a system.
Great question. At the end of the day, I think it comes down to if you were going to launch a new part
Mm,
using milling, molding, whatever your traditional production method is, how would you do how would you do that?
yes.
What role would you know, whether it's your quality engineering department or, your production team, what roles would those people play and engage them in a similar way here? The part that, and we've beaten this drum quite a bit, but we're going to keep doing it. I mentioned I met with some senior executives at the show, and one of them, they're looking at spending a ton of money and would make any additive OEM tickled pink to get a big chunk of it because it's a significant number. I said, go around and just ask companies who can give you a certificate of conformance
Yes.
for how the machine will perform. Like if you bought 50 machines, what kind of performance window or shot group or whatever phrase you want to use, could you expect those 50 machines to perform within dimensionally, et cetera? And then we actually had a beer at my hotel the next day and he's like, nope, nobody could give me that. That is a foundational piece. But as a customer, there is a way you can figure this out on your own. If you are set on a given technology, a given manufacturer, et cetera, you can do your own, call it design of experiments, do a little statistical process control, run a bunch of prints, do some measuring, et cetera. Now, should the hardware OEMs be doing more of that for you and taking that burden off of you? Yes, of course. And if you need help figuring out how to do that, again, we can help help companies through that. But you have to understand how that process is going to perform. And oh my gosh, don't forget to look at post processing.
Mhm.
People love to look at the printer because, hey, it was digital. Now it's physical. I can measure the thing. What happens between when it comes off of that build head and comes out of post processing sometimes is more change than everything else in the system put together. And the importance of, how long does a part stay on the build table before it gets cleaned? And then how long is it cured? And the importance of doing those things the same every time sometimes is greater than the variation from printer to printer
Mhm.
across a given, OEM's fleet. However, if we've got the right people at the table on the front end and you're working with a systems integration partner that can help you with, you know, what is key to quality? And it isn't that they know your part better than you do. They should just be able to ask you the questions about what you're trying to do so that they can take a look at the tech. And when I say tech, we use the phrase tech stack, but all the way from what's the data in the file that's being run through, what layout and support, what slicer, is the part being serialized? If the part is being serialized, is that being manually done by a CAD designer? Is that happening in some other software macro? If it's happening in some other software macro, how much of the part is that piece of software able to change? Is it locked down to where that serialization can only happen in a certain place and before you've ever loaded a file onto that printer or into that machine, it's a good file. All of those things we've quoted. He's semi-famous on this podcast, Corey Jacobs, our VP of operations. But he always says you can't test quality in at the end; you have to build
Yes.
it in, and that starts with the CAD file itself and has to follow through the entire process. But again, most companies have people on their team that know how to do this around other technologies. Sometimes the role we end up playing is more facilitator than 3D printing guru.
Yeah, I love this because I always, customers don't buy parts, they buy predictable outcomes. And I have a great example of what you're talking about where a customer came to us and they said, "Hey, I am getting inconsistent parts. I don't think it's in my design. I'm pretty confident in my material. I'm fairly confident in, I'll call it the technician loading it onto the printer. Where is this happening?" And so we went in, we've done physical, virtual site visits, and it's fascinating where you start to understand diagnostically what's going on and then multiple paths to solve it. Some are pretty cut and dried. One part was preventative maintenance on the machine. Check and done, matching process, employee trained, great. What I think is really interesting is there's a lot of ways you can do environmental controls. Do I need to put this in a chamber? Do I need to have some type of humidity control? Or should I do a software tool that delays when I can start my print so that I know when my people arrive on their third shift or they arrive Monday after the weekend, that part is only sitting there for X amount of time. So you can look at the same problem, which is my part when exposed to this environment changes, and you can address that with labor. You can address that with software. And so what you're talking about in terms of facilitator, they know what's going on and they know where it needs to go. But what is the best use of resources to solve it? Feel like is a conversation we're having again and again. In this particular example, it was don't add more labor. That should be a software innovation that solves that problem where I hit start, it waits to print, it's going to agitate this material so I don't have to worry about variability on that. And it's humanless because my biggest constraint right now is I can't add more FTEs. But if you're thinking about, I'm just looking at the technology, you might just throw people at it instead of I'm looking at a system and I'm looking at variability and cost. What's the right way to broach this? I don't know if you had, you've done a lot of traveling. We both have over the past couple months, but do you have other examples or thoughts like that where maybe once you define what the real problem is, the solution isn't necessarily the first one they'd go to?
Yes. So and I'm not going to use the name of the company. It's kind of like the intro to the true crime shows. The names of the guilty have been changed until the trial is complete. But you hear us advocate for process control all the time in this podcast.
Hmm.
And this is such a great example of why. So things like you touched on with, when you think cycle times and takt
Hmm.
times in your production process.
Yep.
So when the print finishes, how long does it hang there on the build table before it goes to the next step? If that's, removal and then cleaning, or if that's cleaning on the build table and then removal, how, in your cleaning process, if you're using a detergent, a solvent, etc., how many times and for what materials can that get used before it needs to get replaced? If you don't have a standard for that, that's a problem because if that's not under control, again, something like, well, I don't know, do we use it? Do we clean 100 prints in it, 200, 500 until, Jim, the guy in production, happens to think to change it? Because Jim remembering it, that's not a very robust system. But if you don't have that nailed down, it's hard to spot the variability from other things. So this
Hmm.
particular customer, their process would just kind of fall off the table at certain times and they could not figure out, things would be just humming along, yields are great, performance very looks very nicely statistically in control, and then all of a sudden would just fall off the table and chased squirrels from humidity. Is it,
Hmm.
when the first shift comes in on Monday, we've set back the HVAC system, so it's a little warmer in the building. Is it that? Is it and they chased a ton of things. It turned out to be something much more simple, but because they didn't have a standard at every
Mm,
step, it took months to
yeah.
figure this out and a lot of engineering analysis. It did not have to be this hard. Something like I'll go back and pick on the whole, how many parts do we clean in this solvent before we replace it? Uh, you're probably not sure what number to start with. Just pick a number,
Yes.
right? And say pick 50, pick 100, pick something. And you can always change it. But if you don't know what the standard is, you can't improve the process. And again, things like humidity, temperature, your point about agitating the resin.
Mhm.
I've learned by working with enough customers, if you show me all of your print performance over time, before I even see the graph, I'm gonna predict Monday mornings and
Yeah.
right after lunch are the worst performance.
Yes.
And the things that change during those times, whether it's parts remaining in the machine longer, material not properly agitated or up to temperature, those are things that kinda like, again, injection molding machine, you don't just hit the go switch and start spitting out parts. That molding tool is a giant hunk of steel that has to be up to temperature
Hmm.
before you can start running parts. There are elements of additive that are the same, and I think in the metal world, sometimes there's better understanding of this. In the polymer world, people treat it more like a genie in a bottle, and, you rub the printer 3 times, hit the go button. Again, you have to have standards for all those things. When you ask yourselves the question, the parts aren't the same. What changed? Well, when you think of every step in the process, was the solvent old? Was it the temperature in the building when we started? How long had the material been in the vat? What percentage of the material in the vat was new versus old? If you don't have answers to any of those questions, there's a lot of squirrels to chase down and it takes time. And as we all know, time is money. Frankly, even more important than the time and money, it erodes the trust
Hmm.
of your production team. It erodes the trust of your executive team. And most of the time in a corporate environment, you run out of that before you run out of money.
Yeah. Yeah. And, Corey gets two shout outs on this podcast because he always tells me, no standard, no problem. And so we talk a lot about standards and each part of those process steps. The other part of it I want to talk about is how do you introduce new into something that's qualified? So we have customers where they may be firmly in the product development world, but they'll have production qualified printers and they'll have R&D prototyping qualified printers. And that looks like if I'm going to update my firmware. How do I know when I do that, nothing has material changed? If I'm going to update my software, how do I know that? And similar to things that aren't immediately obvious, to your point, if you don't have standards, I think that can be a black box for people. We're like, no, I know how long I'm supposed to clean it and cure it, and my technicians are trained, and I made sure everything was clean. Yeah, that's great. That's fantastic. But then how do you introduce the new? I want to talk a little bit about how do we solve for that inconsistency and how we've maybe tackled that problem with customers. Because I know we've done a lot on the software firmware realm, separate from everything you talked about in the physical realm.
We have, and to your point, and this is so common in manufacturing facilities, it's machines that are running firmware or running Windows 10 because it's working and we don't want to change anything. And, B9 is no different as a manufacturer. I mean, we had to go through a process recently. We had a piece of optical metrology equipment that, there's a laptop that drives all that. It needed a Windows upgrade. And of course, our team is, we want to be proactive about this, but we had a representative from the manufacturer of the equipment here while we did it because we didn't want to mess that up. In the event, let's go to fantasy world where the feasibility works well. You have a QA/QC process and you could deploy, 30 of some manufacturers' machines and a bunch of consumables onto your production floor and the parts would be amazing. Let's pretend we're there. How are you going to control, firmware updates? How will you know before you deploy them that nothing will change in the printed output? Does your partner have a plan for that? Because the nice thing about an injection mold is if you get your temperatures and pressures right and the materials right, usually it runs pretty good. A firmware update that may have added or changed a feature that some other customer that does something totally different with their machine wanted could bring your production process to its knees. Do you have, and again, here you have to plan ahead
Mhm.
and look at what's key to quality. Some of the things that are key to quality. I'm running CAM software and firmware that enable production to my standard. Are you telling your supplier, tell me everything from your perspective that is key to this outcome? Your point about customers don't want parts, they want predictable outcomes. Understanding how to quantify those things, and then similar to what you would do on your production floor around lot to lot, incoming inspection, et cetera. Again, if you go to any even remotely mature production organization, they have incoming inspection standards, right? Whether it is a batch of metal parts or a batch of electromechanical parts. What do they do for their 3D printing material? Well, I don't know. These guys, I'm sure they make it the same way every time. How much variation can you tolerate and maintain? When you think, and we're nerding out a little bit here, but you think about depth of penetration, DPIY, things like that and we're talking about liquid photopolymer, but whether you're using metal powder, filament powder, or material jetting, how do I know that that is the same or the same enough that I can expect the same output? What kind of incoming inspection process would you use? Most people have no idea. And so you are doing incoming inspection on a part that comes from some 50-year-old company that's been, been making these parts for you for a long time. And you're not doing any incoming inspection on something from a company that was a startup 3 years ago
Mm,
that invented this cool material technology. And now they're shipping it all over the world. Again, risk, right?
mhm,
And it extends down the line. I mean, how things like your customer support team. If your product has a 3D printed part in it, do they need to know the difference? When a customer calls in and says, "Hey, I have a problem," if you're doing a mix of traditionally produced and additively produced, that batch to batch, lot to lot, thinking it all the way through in terms of how will I support this in the field?
mm,
It sounds complex. The only reason it would be complex is if your company doesn't make anything today. If you make something today, you already have a set of processes that you use to do this for traditional technology. And much of it can carry over, especially conceptually, probably 99% of it carries over. You just have to figure out a new way, again, if it's incoming inspection, whatever the case may be, a new way to do that based around this product.
yeah. And a couple of, because we like to do tactical, kind of practical takeaways on this too. Some very real examples we've done is a company may be serializing parts in CAD and reslicing every time. That's great for product development, but when you go to production, you don't want a variable to be, did something happen with the slicer? So do I have a software capability? And we've done this with customers where we're like, we will help you serialize your parts where it's only slicing a non-critical part where that serialization occurs. Everything else is locked down. Same thing on the material side. Totally different company, but same production environment where that incoming inspection, can you help me develop a process where I would know if that material changed and I would understand enough chemically what's going on? And then in the print performance to ascertain that before I get a whole bunch of it in? Yes, we've done that too. So I just share these examples with our audience. To your point, it's not platitude level. There are practical ways you can start to implement this, but it's that mindset of not serialization isn't the production capability. Serialization without slicing as a variability is a production capability. And I just want to help the audience grasp that because it's the same principles, but you got to think about them in this system.
Absolutely. What's the phrase you always use about the digital, physical something?
Yeah, cyber physical
There you
system.
go. It's
Yeah.
a si
I'm glad I remembered what I always say.
that could have gotten awkward if she couldn't come up with it, but, this being I love Danny's phrase of a cyber physical system where something goes from the digital to the physical, and so often we're quick to point at the physical things of, "Ooh, yep, the printer must be out of calibration, the parts aren't the same." What happened in the digital world? And
Yeah.
to Danny's point, do you have controls for that? When you are looking at partners, whether it's a hardware OEM that, you're using their CAM software, et cetera, to what level can they commit to you that no change will happen in that software that would impact printed output that you don't get notified ahead of time? Similarly, whether it's a material, will they sign a contract with you that says they won't change their supplier without notifying you? I mean,
Yes.
and
Yes.
and many of these companies are small, immature, and it sounds like I'm giving you 101 reasons not to use additive. That's not my goal. I'm just telling you these are the things you have to pay attention to. And no different than if you are a large medical device company, you're probably not going to go source some new component from a company that's been around 2 years, isn't a qualified vendor in your system, doesn't have a robust, they couldn't tell you when it left their plant that it conformed, and they can't give you a process to be able to tell when it enters your plant that it conforms. You wouldn't use that supplier. So just don't do that in additive either.
Mm-hmm.
If you don't like to hit your thumb with a hammer, just because it's a different color hammer,
Yeah. Don't do it.
don't do it.
Don't do it.
You have smart analogies like cyber physical systems, and I'm talking about hitting myself on the thumb with a hammer, but
We've spent quite a bit of time, I'll call it dwelling in kind of the technical production process. I want to, as we wrap up this podcast, I want to go back to the business case. I mean, you mentioned it earlier where sometimes the capital you run out of first is executive goodwill, not necessarily financial. How does either getting this right, or even I would say companies making the case for here's why I need to go have some dedicated resourcing, whether it's partnership or internal, around understanding my QA/QC tool set in additive, how does that help the business case? You are in a position that a lot of the folks on our podcast are having to present to. They're having to present to a C-level person on why this is important. Give them some coaching maybe on what that looks like, what you would care about, and how to bring that to life.
happy to do that. Some of these themes are going to sound familiar. Let's take this kind of new production technology implementation element. So if I was going to pitch to my CEO or, depending on the size of the company, maybe it's, VP of technology, whatever it
Mhm.
might be. If I'm going to pitch, here's how I think we can use additive to grow faster, save money, or reduce risk. Because little hint, if you're pitching to anybody at an executive level, their brain has basically three buckets. It's how do we grow? How do we keep more of the dollars we bring in the door? And how do we minimize risk? Almost everything falls into one of those three buckets. If I am going to make that pitch, I need to think ahead about if I meet with the plant manager that I think this might go, whatever facility I think this might go into, what would be the workforce implications? What would be the procurement implications? Do we have anybody on that team that has the knowledge of how to go buy this instead of the sheet metal or whatever they might normally procure? And some of these questions about what's in our procurement contracts, things about how do I know the output of your software doesn't change, et cetera, et cetera. If you plan ahead for those things and you can show when you make your pitch, obviously they probably don't want you to drag them through every one of those details. What they want to know is you have thought of those things and you have a plan. When we talk about running out of executive goodwill, in my experience, it tends to come from kind of two areas. They're usually going to give you some grace on the proving the feasibility part. And if there's real R&D to be done, like, hey, we're not sure there is a material that's going to, meet our, you know, whether it's performance over time or, flame retardant, whatever that might be, it's pretty easy to get a pot of money to kind of deal with that uncertainty. The, ooh, it turned out our supplier can't because they sell this software to people all over the world, they won't guarantee to us that they're not going to make a change without telling us. Well, you could have known that ahead of time. And again, they're a lot less tolerant of things that were knowable. Like, hey, if you're thinking about using, and maybe you've got it narrowed down to 3 companies, do you have somebody from procurement involved to say,
Mhm.
help me vet these companies? Who would be the best one? Because not only when you're making the pitch at the C level, but when it comes time to implement, if the plant manager looks at the lady who's, VP of supply chain, and she looks him in the eye and says, yes, we vetted this vendor and we're confident they meet the same requirements that, the other vendors who are shipping parts into your facility meet, this guy's blood pressure is going to be way lower. So it's identifying all those things on the front end, not that you know the answers to them all, but that you know the questions that have to get asked will both A, inspire confidence and frankly inform on the budget for time and resources it's going to take to do this. The amount of, you know, over promising and under delivering, sometimes we pick on our industry for doing that, but the people tasked with implementing these technologies internally in companies, I find, are often um, dramatically overly optimistic and neglect a number of these things that are, they're details, but the old saying goes, the devil's in the details.
Mm.
If the part's feasible and you like the material and the software's good and all those other things, but the company you want to source the material from can't make your VP of supply chain happy and can't qualify as a vendor from a stability and having mature internal quality processes of their own, your whole project's now dead in the water. So it's, and I guess my advice to CEOs or, executives who are in charge of these additive implementations or transformations, don't just assign it to your engineer who's great with additive. Maybe you pair that lady with somebody who has implemented new production technology in 6 different
Mhm.
plants around the world. Somebody who will know about all these other questions that your additive expert from the R&D team might be incredibly intelligent, but just doesn't have exposure to some of these other things. And make sure that the team is bringing you a proposal that grasps all of the, whether it's items that have to be investigated, dollars or time that's going to have to be spent, resource that might need to be available. If your supply chain organization is undergoing a major supply chain audit and you come along and say, hey, I just found 3 cool things from 3 companies that, started on Kickstarter a year ago. Can you guys send somebody to their plants and do a quality audit? And, you know, probably not going to happen. So a little awareness of what that downstream process is, and as the executive making the decision, understanding the questions that need to be asked, not every single one, but having a cross-functional enough team that you think you'll catch 95% of them. Again, you don't have to catch 100% of them up front. I know as a business leader, sometimes we get caught off guard by something that we couldn't have known, and I don't get too frustrated with our team about that. If it wasn't knowable and it happens, we'll deal with it, right? That's we have a bunch of smart leaders here, great employees, we'll work through that. The things that just give me an aneurysm are the things that were knowable when we missed them, and I'm confident that's not just a Sean Anderson trait. I'm
Yeah.
confident that that's most executives, and if you tell the team ahead of time and say, the unknowables, you're going to get no flack from me about the unknowables. Please don't bring me something that was knowable. Do your due diligence up front. That would be my advice to both the team bringing it and the executive approving it. And that cross functional element is just vital.
Yeah, I agree. And because I love a good anecdote. We'll end on this before we wrap it up. But things that even I wasn't thinking about until I met with a cross functional team back to supply chain is it's not only how durable is this? How long have you been in business? Will you notify me of changes? What does your outgoing and incoming quality inspection look like? But they were asking things with a major company that I was on a call with. If process is novel, who owns IP? How do we determine that? What does that contract look like? And this was all from technical sourcing folks. It was, well, if it's commercially available components, it looks like X. If we co-develop something together, it might look like Y. Who from your team would even be able to discern what parts of that each owns? And I share that because very similar, they also had questions on exclusivity. If what we develop together is so valuable to my business that I need the competitive edge, what would it take for us to mutually say yes to that? And there's these business structures that aren't always in a quality audit that I would just encourage folks to think about cross-functionally, because that was not coming from an engineer. That was coming from the sourcing team, and it was all about business intelligence and competitive advantage. So your point about cross-functional teams and what questions should I ask that are knowable ahead of time, those are. You may not know if you want it,
Right.
but you should know, can we address it if I do?
Yep. Is there a mechanism? Sometimes it comes down to basic things. If you go to a supplier and you say, so what's your on-time delivery percentage?
Yes,
You know,
yes.
what's your RMA rate, et cetera? And they don't know.
Yeah.
If they can't control their processes, they dang sure can't control yours.
Yes.
It's a little bit obvious when you are a supply chain professional, not obvious when you are additive manufacturing, R&D, engineer, process development professional. And I can assure you it's not obvious because I talk to these people all the time. Again, they're smart people. Those just aren't the kind of things they're used to thinking about. So you've got to get other people in that conversation that they'll ask those questions.
Yeah. Well, I hope this was useful, and if you're serious about scaling additive, if you take nothing else away, stop thinking about just printers and start thinking about systems, because that's where consistency and real production comes from. And as we've spoken ad nauseum, that same mindset applies if you're a manufacturer of hardware or materials as well, because at the end of the day, customers aren't buying additive manufacturing, they're buying repeatability. And the companies that figure that out are the ones that are going to scale.
There's one thing to take away from today's conversation. It's this. As Dani said, additive doesn't scale because of what it can do. It scales because of what it can do consistently. The companies that are winning in the space aren't chasing the new machine or the latest material. They're building controlled, repeatable systems that deliver predictable outcomes. That's the difference between a successful print and a successful manufacturing capability. If you're working through these challenges or you're trying to move beyond prototyping, we'd love to connect. We'd love to have these types of conversations around your actual business and your context. You can reach out to us on LinkedIn or email us at info@additiveadvantage.services. You can follow us on Apple or Spotify podcasts, and you can see the full episode on YouTube at the Additive Advantage Podcast. If you found value in this conversation, we'd love a 5-star review or rating. That really helps us to continue the show. And don't hesitate to give us feedback on what you'd like to hear more or less about in the future.
Yes.